Alright, so today on this video, we are going to be going over long division with polynomials. So in the last video, we went over, hold on. So we went over how to, multiply polynomials. And so if we can multiply two numbers, that means that we can divide them. So today we're going to look at what polynomial division looks like, because as I imagine, with the polynomial multiplication, the division is going to sound kind of weird at first. It's like, what do you mean I can divide that? That doesn't look like I can divide that. I promise you, you can divide it. And so let's go to the board and look at some examples. So let's say let's say someone writes, so x plus 3 times x plus, or x minus 1. Okay, so these are two things that I'm multiplying together. So, okay, so if I multiply them together, I should get x squared plus 2x minus 3. If you want to pause the video and double check my math on this, feel absolutely free. You're more than welcome to. But now I have x squared plus 2x minus 3. Okay, so if I can multiply in order to get this number, I should be able to divide and get one of the things I started with. So let's say I divide this by x plus 3. There's a couple ways that I can do this. So one of the things you can do is, if you're familiar with factoring, you can factor this out. So since we know that this guy and this guy are the same, we could actually rewrite that as x plus 3 times x minus 1, and then just write that over x plus 3. And because these two are being multiplied, then these would cancel. We should just get x minus 1. So we know that at the end of this division, we should just get x minus 1. But here's the thing. You won't always know what the factors are, and sometimes you won't even be able to factor. So in those situations, we're going to have to try a different strategy. And that's what we're going to be talking about today with long division. So let's assume that I didn't know any of that stuff up top. The only thing I know is that someone asked me, hey, I want you to do this division. What is it going to look like? Well, before we get to that, let's talk about how we do long division with numbers normally. So if we were doing this with just normal numbers, what would that look like? So let's say we have 12 divided by 3. Okay. So if we do that in long division, the first number goes inside the the dividing sign, the divisor, and then we put the 3 on the outside. So the number we're dividing by always goes on the outside. Fair enough. Okay. So the first thing I got to ask myself is, I do this digit by digit. So first term, first term. So how many times can 3 go into 1? Well, it can't, so it goes in 0 times. So then what I do is I do 0 times 3, 0 times 3 is 0. So I'm going to subtract that 0. Now, I know what you're thinking. You're probably thinking, why are you describing all of these steps? We do this all the time. Isn't it obvious what we're supposed to do? And yes and no. So it seems obvious right now. It might become more complicated later. So now we're doing first term to first term. So now the first term is 12. So how many times can 3 go into 12? Well, that would be 4. So then we do 4 times 3. 4 times 3 is 12. So then we subtract that. 12 minus 12 is 0. And so we have a remainder of 0. So we are going to keep this bit in mind whenever we go do our long division, so that we can kind of parallel the two of them. So we got our instructions right there. And now we're going to take this guy. And the first thing we're going to do is we're going to rewrite this guy, because goodness gracious me, that looks awful. That doesn't even look like the dividing sign I had before. So we are going to make this look a little bit cleaner. So we got x squared plus 2x minus 3. And we are dividing that by x plus 3. Okay, so now we're going to put it, we got our long division sign. And actually, I'm going to move that up some. So we got our long division sign. And this guy goes on the inside. Because just like before, when it was 12 divided by 3, put 12 on the inside, 3 on the outside. So on the inside, I'm going to have x squared plus 2x minus 3. And the number we're dividing by, in this case the expression we're dividing by, x plus 3, is going to go on the outside. Okay, So here is where that thing I pointed out before is going to become relevant. So the first term that we're using is x on the outside, and the first term on the inside is x squared. So actually here, let me change that to different colors. So we got x here, x there. Okay, so if I were to ask myself, okay, so x goes into x squared how many times? Okay, so that would be x squared divided by x, so that would just be x. So the number I'm going to put on top is an x. Fair? So now I know, so I need to use my leading term to get to the new leading term. So I'm always going from the front on the outside to the front on the inside. You might be wondering, well, what if I can't do that? And don't worry about that. We will talk about what happens when we get there. So now, so I do the number I have, so the term I have up top, times the divisor, and then I subtract that. So I'm going to do x times x plus 3. So actually, let me change that color. So I got x times x plus 3. So x times x plus 3 is going to be x squared plus 3x. And I'm going to put that in parentheses. So this is what happens when I multiply. So over here, I multiply and then I subtracted, right? So that means I need to subtract this term from what's inside the divisor sign. So when I subtract it, I need to distribute my negative to both. So I have a negative x squared minus 3x. Okay, so remember, so multiply what's on top times your term. And then when you subtract it, you distribute a negative to both. So multiply and then flip your terms. So the x squared and the x squared cancel. That was on purpose. That was the way we wanted it to be. And now we've got 2x minus 3x. So 2x minus 3x is going to be a negative 1x. And then we are going to bring the next term down with us. So that is minus 3. Okay, so now I still need to get from my first term to my first term. So now, instead of going from x to x squared, I'm going from negative x, or I'm going from x to negative x. So I need to do, negative x divided by x. So the inside divided by the outside, that gives me a negative 1. So I'm going to put minus 1 right here. And now I'm going to switch colors. So now I'm going to do that negative 1, just the negative 1, times my x plus 3. So I'm going to write this down here. So negative 1 times x plus 3, that's going to be negative x minus 3. Okay, so negative 1 times x plus 3 is negative x minus 3. Fair enough. But I still need to distribute that negative in there. So I multiply the negative in. So I switch the signs. And when I switch the signs, I'm going to get positive 1x plus 3. Okay, awesome. So now that cancels. That cancels. I'm left with 0, which is my remainder. And my answer, my final answer, is going to be this guy up here. So the answer to what is x squared plus 2x minus 3 divided by x plus 3, that answer is going to be x minus 1. So just like before when we split it up, we can do the long division way to figure out what it is if we don't know. So the steps are in order. So it's first term to first term. So first term for both the inside and the outside. Then you multiply. So you multiply your term up top times your term on the side. Then you subtract. So whatever you got when you multiplied, you subtract that. And then fourth, you just bring the next term down. So you bring down the next term. So this is the order that we're going to be doing stuff in. And I am going to set this off kind of to the side. Here, I'm going to set it right here. And I'll clean this up a bit so that there's not all this junk in the way. Got a bunch of stuff. Okay. So this is how we do it. So start with your first term, then multiply by what you get, then subtract, then bring down. So we are going to do that with a different question that we don't know the answer to this time. So we don't know the answer. Brand new question, new math, who this, we're going to make this work. All right, so let's say this time we've got x squared plus 5. Okay, we're dividing that by x minus 2. Okay, so this isn't going to go evenly. We're going to have a remainder here. That's okay. So on the top, we have x squared. And now you might be thinking to yourself, oh, so now I just write plus 5, right? Well, normally that's okay. But we don't have any x terms here. So there's no x terms up here. So we're going to write plus 0x. Now, the reason for this is sometimes when you multiply, you're going to get powers of x. So if you have x squared, you're going to have some kind of x. That's just kind of the way it works. So if they don't write the x, you write the x there instead. So we wrote a 0 there for the x, and we're dividing by x minus 2. Okay. So step 1, first term. So how do I get from x to x squared? Well, I multiply by x. So I do that. That'll give me x squared minus 2x. And I am subtracting that. So when I do minus, I'll do minus x squared plus 2x. Okay. So the first one cancels, all according to plan. 0x plus 2x is just going to be 2x. So then we got plus 5. Okay, so now I have a new leading term to deal with. So how do I get from x to 2x? Well, I multiply by positive 2. So this time, when I multiply this in, I am going to get, so I'm going to get 2x minus 4. But I need to subtract it. So when I go to subtract it, so distribute the negative. So negative 2x plus 4. Okay, so the 2x's cancel, and I'm left with 9, so I have a remainder of 9. So the answer to my question is going to be this and this. So my answer is x plus 2 with a remainder of 9. So, and that'll be it. That's the answer to my question. So this is it kind of in fast forward. So make sure you go first term to first term, then you multiply and subtract. First term to first term, multiply and subtract. And then, whatever is left on top and your remainder, that is your answer. So this is long division with polynomials. So now, as you might have noticed, just by kind of, how long we've been doing this, this is kind of a lengthy process. This process takes a while. It is the proper way to do polynomial long division. So most of the time we want to do this, but there's another way to do this that's a little bit faster called synthetic division. So synthetic division is something we can do when we're dividing by a binomial. So binomial, remember, just means two terms. So synthetic division is this idea of, oh my goodness, I need to do long division. Like, there's so many problems on here. I have to do it over and over and over again. How the heck am I even going to do this? Well, synthetic division is a way to make this faster. So let's switch back over the board, and I will show you how synthetic division works. So synthetic division is this idea of, so let's say I have 3x to the third minus 4x squared plus 5x minus 3. All of that divided by x plus 1. So this would be a very long division problem. We'd have to multiply several times, got to bring stuff down several times. It's a big, long process that we would have to do. But here's a neat thing. So all of these powers of x's have coefficients. So we have x to the third, we have x squared, we have x, and we have a constant. So basically, whatever the highest power of x, we line them up like this. So what we're going to do is we're going to write the coefficients of these guys. So we're going to write down the 3, the negative 4, the 5, and the negative 3. And what we're going to do is in here, we are going to put an interesting thing. So when we do long division, this term, right, this x plus 1, we always subtract it whenever we're doing stuff. So instead of putting, a plus 1 in here for my dividing term, I'm going to put a minus 1. So you always put the opposite of whatever you're dividing by in here. So instead of x plus 1, I'm going to put minus 1. The reason is that it's the opposite sign, because, when I go to, if I was gonna, actually do this, I was gonna have to multiply -1 by a negative at some point, right? So the idea is here, I just went ahead and did it ahead of time. That way I wouldn't have to do it over and over again. So the first term that comes down is going to be a 3. So real quick, if we're doing division, if we divided off an x, so we had x to the third, if we removed an x, we would have x squared. So this would be an x squared term. So now what we're going to do is we're going to multiply the -1 times 3. So this is to represent how, the 1 would have been multiplied by the 3, x squared, and then we would have subtracted it. So we're going to do the -1 times 3. That gives us a -3. Okay, so then we just add these terms. So -4 plus -3, that's -7. And that would have been just a regular x. So now we're going to multiply by the -1 again. So -1 times 7 is +7. So 5 plus 7, that's 12. This would be a constant because now we've used up all our x's. And then we do -1 times 12. That'd be -12. So -3 plus -12, that's going to be a -15. This guy would be our remainder. So if we do this division, so if we did all this division using long division, we would wind up with our answer basically being what we have on the bottom over here. So we'd have 3x squared minus 7x plus 12 with a remainder of -15. And you'll notice that that actually went so much faster than the other method, and I was explaining it for the first time. So even the longest version of this method is taking less time than the previous version. So this is a way to do it faster and easier. So this is the setup. So the setup is, so you write all your powers of x, you write their coefficients, that is the numbers in front, you put the opposite of what you're dividing by. So if you're dividing by x plus 1, you put -1 up here, and then you just bring down, multiply, add, multiply, add, multiply, add. And so we're going to do another one of these, but we're going to go much faster now. So now instead of worrying about all the explanations, we're just going to do it. We're just going to make it happen. And I'll even make it longer just so that it doesn't end right away. So x to the 5th minus 3x to the 4th plus 2x to the 3rd minus 5x squared and minus 1x plus 7. 1 second, I need to sneeze. Okay, I sneezed. Sorry, I muted the mic. I didn't want to stop the recording. So, and let's say we divide by x minus 2. Okay. So we're starting off with x to the 5th, then 4th, then 3rd, then square, then x, then constant. So this one would have been really annoying to have to do out with long division. So we've got 1x to the 5th, -3x to the 4th, +2x cubed, -5x squared, -1x, and then a +7. So we're dividing by x minus 2, so the opposite of -2 would be +2. Okay, so let's see how this one fares. So we should be getting x to the 4th, and then I'm not going to fill in the rest because you'll see the fast way we do it. So 1 is 1. I'm glad we established that. So 1 times 2 is 2. Excellent. -3 plus +2 is going to be a -1. -1 times 2 is going to be -2. So we got a 0 here. That's neat. So then 0 times 2 is 0. -5 plus 0 is going to be -5. -5 times 2 is going to be -10. -10 times 2 is -11. -11 times 2 is going to be -22. So 7 plus -22 is going to be -15. So this is our remainder. So that's x to the 4th, which means this should be x to the 3rd, x squared, x, and the constant. All right, cool. So we can just write our answer now because we know that our answer is just going to be the stuff on bottom. So we have 1x to the 4th minus 1x cubed. There is no x squared because this is a 0, so basically there's no x squared term to speak of. Minus 5x minus 11, and then we have a remainder of -15. Okay, cool. So that's it. We're done. This whole big scary problem that probably would have taken 8 or so minutes to have to do by hand with long division. We did it all really quick using synthetic division. Only took, what was it, 2 minutes, and I sneezed in the middle. So yeah, so this is pretty fast method, much faster than having to do long division. I would recommend practicing with both, just in case someone throws you a weird curveball. That person probably being me in the independent practice, but just give those a shot with both of them. Try out both methods, and you should be good to go. So, and that is going to cover us for synthetic and long division. And so now let's cut back to the presentation. All right, so that's synthetic division. And now that is the end of lesson 5, I want to say, unless we got something else. Nope. So this is the question that we're going to have during the synchronous hours. And so, yeah, those are how we do division of polynomials. So that's one I think, it's another one kind of like multiplication where I think you should practice it a bit to see which one you're more comfortable with. I know students tend to like synthetic division more just because it's like, oh, multiply, add, multiply, add, multiply, add. It's much simpler than having to, first you first you divide so you know what you're multiplying by, then you multiply by it, then you subtract it, so there's a lot of steps in long division, which is why synthetic division exists, to kind of simplify that process once you have an understanding of what you're doing. I would recommend that you get very familiar with both. But yeah, that's going to be it for today, and I will see you guys in the next one. Y'all have an awesome day. Bye-bye.